All right, so I'm just going to walk through those 3 practice problems from yesterday just to make sure that if you need to hear it and watch me work it out, if you made a mistake, you can understand maybe where something went wrong. So the first example, it asks how many atoms are found in 0.2 moles of silver. So we have our given, that 0.2 moles. And again, the one habit I like to get into is going ahead and labeling with what it is. Remember, we're lazy and we can abbreviate the moles, MOL. It's asking for atoms. The only conversion factor we have at this point is that 1 mole is equal to the 6.022 times 10 to the 23rd. And your 2 label options are either atoms, if you're talking about an element, or molecules, or MQs, because again, we're lazy, and if that's talking about a compound, okay? So we're looking at silver, so that's why it's talking about atoms, because it's an individual element. So that means in order for moles to cancel out, moles need to go in the bottom. To go to the unit we're looking for, we're solving for atoms, we're going to put Avogadro's constant in the top. So mathematically, what you needed to do here to solve was to multiply it out. What I got for an answer is, move my screen, 1.20 times 10 to the 23rd. Don't forget those units, so moles canceled out. So I can label this as atoms of silver. Okay? So then in example 2, it asks how many moles are found in 7.81 times 10 to the 21st atoms of copper. So I can go ahead and label, or start with my given. We're still talking about atoms because we are talking about an element. So atoms, Cu. And unfortunately, we don't have an abbreviation for atoms. So this problem is different because our given unit is atoms versus moles. So it's very similar to example 1. The only thing we're going to see different is Avogadro's constant needs to go in the bottom here because we're starting with atoms. So in order for that unit to cancel out, we need to put that in the bottom so it divides out. So 1 mole will be in the top. So how this problem is going to be different is you should have multiplied by 1 and divided. So essentially you're just dividing. So you're going to take 7.8 times 10 to the 21st divided by 6.022 times 10 to the 23rd. You do get a relatively kind of small number for this, so I want an extra decimal place further. You should have got somewhere in the ballpark of 0.013 moles of copper. I've already looked at some of your guys' work that you turned in. I saw with the rounding 0.01 moles works of copper. Or I did see some people use scientific notation, so something like 1.3 times 10 to the negative second moles of copper. Those are all perfectly acceptable answers for that particular problem. Last but not least, this one we're working with molecules now because we have a compound, sulfur dioxide. So we have our given of 1.28 moles of SO2. And it wants to know how many molecules we're working with. So we're starting with moles, so that means mole needs to go in the bottom. Avogadro's constant is going to be the top. And instead of atoms, I'm going to label this as MQs for molecules because, again, we're working with compound. So this one is going to be a multiplication to solve. So we should get a much larger number. So we get 7.71 times 10 to the 23rd MQs of SO2. My goal is to give you guys individual feedback before this video, but if you're finding that you are getting the wrong answers but all of your work is the same, that's a calculator issue. You need to reach out to me, take a picture of the calculator. If you need me to try to help you find one based on the kind of device you have available, I can help you work on finding a good calculator. So check in with me if you have any questions or need help.